In this next video, we're going to be looking at the small changes part of the 0606 additional mathematics course on the chapter of differentiation. Now, if we think about a function, y equals f of x, and let's say it looks like this, what we want to be able to do is say if y changes a small amount or if x changes a small amount, what is the corresponding change in the x or the y? So if I take a point here and I say that, let's say that x changes by a small amount, so x increases by h. What I want to know is, well, what is this y change going to be? This only works if h is small. If h is large, then it doesn't work. So in the question, we'll always say, assuming the step h is small. Now, what we should be able to note, right, is that if the change in x, which we'll call delta x, and delta y is small enough, that's the gradient, changing in y over changing in x, that's the gradient of the red line. If the step is small enough, then the gradient of the function, which I'll put in pink here, is basically the same. It's not exactly the same, but it's basically the same. And so what we say is that it's approximately equal to the gradient. This is the theory behind what we're looking at. Basically, if the gap is small enough, if the step h is small enough, the gradient of the function is equal to the change in y over the change in x, the gradient of the step. Let's have an example. Let's say that we've got a function, y equals x cubed plus 4, and I want to know the change in y when x goes from 2 to 2 plus h, where h is small. And the question will say h is small. Now what we know is that dy by dx is delta y by delta x. Delta y being the change in y, that's what we want to find out. Delta x being the change in x, which obviously in this case goes from 2 to 2 plus h is h. So first thing we want to do is find dy by dx. Dy by dx, differentiator is 3x squared, and we want to know at that point, so at 2. So at x equals 2, we do 3 times 2 squared, which is 12. That tells me this part here. That tells me dy by dx is 12. Now, I know delta x because x goes from 2 to 2 plus h, so it's h. And therefore, what I can do is I can say, well, 12 equals delta y over h. And therefore delta y is 12 times h. Now if the question wasn't 2 to 2 plus h, it was, let's say, 2 to 2.01, well then h is just 0.01, so you can just sub h equals 0.01 in, 12 times 0.01, which would be 0.12. And what that means, coming back to the question, is, let's say this was the function x cubed plus 4. If the change in h, or change in x, sorry, is 0.01, the change in y, which is this in blue, would be the corresponding 0.12. Here's an example of another question. We have a sphere, which has volume 4 over 3 pi r cubed, and the radius is going to go from 10 to 10 plus p. What I want to find is the approximate change in the volume. So the question is saying, well, dv by dr is approximately delta v by delta r. Now, dv by dr, if we differentiate that, is 4 pi r squared. And that's approximately equal to delta v, which is what we want to find, over delta r goes from 10 to 10 plus p, which is just p. I know r is 10 initially, so I just substitute that in. So I do 4 times pi times 10 squared is approximately equal to delta v over p, and therefore 400 pi times by p is approximately equal to delta v.